Good evening everyone. So today in this class we will see the node by node reduction procedure for a graph matrix. In previous class we have seen the reduction procedure for a control flow graph. So the difference between the reduction procedure and node by node reduction procedure is, so in reduction procedure we are applying the procedure for reducing the control flow graph. Here in this particular node by node reduction procedure we are applying the procedure for minimizing the graph matrix. It means whatever the control flow graph, that will be converted into graph matrix, and the procedure we are applying on a matrix. That's what is called the node by node reduction procedure. In reduction procedure we have seen the path sum, path product and loop. Here also we'll apply the same rules but in a different manner. So whenever we are trying to remove one node, so we have to see whether that node contains any loops. So loops will be there at diagonal elements. So 1, 1, 2, 2, 3, 3 and so on. So at 3, 3 it means 3, 3, it's a loop. 4, 4, 5, 5, it's a loop. So before removing any node, so we have to see whether there is any loop. If there is any loop, we have to remove that loop by multiplying that loop element to its corresponding row elements. For example, if the loop element is at 5, 5, I am trying to remove that element. So I have to multiply that 5, 5 to 5, 1, 5, 2, 5, 3, 5, 4. After that, we have to see whether there is any elements at column 5. After removing the loop, we have to see whether there is any column elements. So if there is any column elements of that particular node which we are trying to remove, so we have to multiply that element also to its corresponding row elements. So after that, so whatever the row elements is there, corresponding row elements is there, we have to add to its above row elements. So loop is completed by multiplying with its row elements, as well as we are checking whether there is any corresponding column elements. So we are multiplying it to its corresponding row elements, and finally we are applying the parallel rule. So whatever the node we are trying to remove, those elements will be summed with its previous row elements. So after that, so we will remove the node. So this process will continue till all the elements except 1 and 2, nothing but 2 by 2 matrix. Up to 2 by 2 matrix, this procedure will be continued. So for example, see here, this is a matrix which we are going to apply node by node reduction procedure. So first thing, so I am trying to remove the node 5. So I have to remove this node 5. So before removing node 5, I have to see whether there is any loop element. See 1, 1, 2, 2, 3, 3, 4, 5 and 5, 5. So this is a loop. H. So first, before removing the loop, I have to multiply this loop element with its corresponding row elements. So corresponding row is 5 and corresponding row elements is G and H, G and E. So I have to multiply this H with 5, 2 and 5, 3. So G, H asterisk, because it is a loop, that's why I am placing it as an asterisk, as well as EH asterisk. So this will be removed. So after that I have to check whether there is any column elements of that row. So see, there is a column elements 5. This is row 5, column 5. So and there is a element F. By this particular element to its corresponding row. To its corresponding means whatever the row I am removing. So I am removing the node 5. So I have to multiply this with 5. Node 5 means FGH asterisk and FEH asterisk. So there is no element at column 5. After that, whatever the row elements is there, corresponding row elements is there, this will be summed with its above row. So above row is node 4. So node 4, so we have sum means C plus FGH asterisk and there is no element. So FEH asterisk. See here, C plus FGH asterisk FEH. So there is no elements at node row 5 as well as column 5. So now it can be removed. Now it can be removed. Similarly for node 4. So I am trying to remove the node 4. So there is no loop because 4 comma 4 is empty. So no loop. So I have to check whether there is any column element. So I have to multiply this column element to its corresponding row. So corresponding row is again it's a 4. So B of C plus FGH asterisk and B FEH asterisk. Again this particular row will be summed with its above row. So means D of B plus C of FGH asterisk and B FEH asterisk. So now this will be removed. Again remove node 3. So I have to see whether there is any diagonal element. So this is a diagonal. This will become the loop. This will become the loop. So sorry, this should not be here. This should not be here. So I have to this one. Take this one. So D plus B of C plus FGH asterisk B FEH asterisk whole asterisk. Whole asterisk. And again 3 A. So this A will be multiplied. So A of D plus B of. So this will be the expression. Again this should be summed with its above row. So above row and this node 3 will be no element. So it will be removed. So node 3 is removed. And finally the matrix which I am getting is this one 2 by 2. So we have to stop here. So if we apply the same procedure once again, this will become whole asterisk. Then our expression will be wrong. So simply we have to take it to above row and 1 comma 2. This will be the our path expression. So A of D plus B of C plus F G H asterisk B F E H asterisk whole asterisk. This will be the final expression or node by node reduction expression for the 5 by 5 matrix which I have taken. Here also we are applying the same rules but in a different manner. Diagonal elements will be considered as a loop and that loop will be multiplied with its corresponding row. Again I am checking for the column elements. If there is any column elements I am multiplying with its corresponding row. After that, so whatever the row that is I am trying to remove, so that elements will be summed with its above row. So then there will be no element so and so node row as well as the column. So then it will be removed. So this procedure will be continued till we will get 2 by 2 matrix. So this is all about the node by node reduction procedure for a matrix. So thank you. We will see the next topic in next class.